Hi, this is Mike Butler with the Process Engineer School. Today we're talking about control systems in a manufacturing plant. We're going to go through the introduction. We're going to introduce a few liquid dosing process control concepts. So we're going to do this by walking through an example process flow diagram, a typical setup that you'll see many places throughout a manufacturing plant. We'll go through the process control systems that are required in order to make a flow rate controlled to a set point. We'll also go through a few similar systems, so not just the single setup that we talked through in the example. So the example that we will start with though is the storage tank is going, there's liquid in the storage tank that is being pumped through a positive displacement pump that's going through a flow meter that's going through an on-off valve that is then going into a main header or a storage tank or wherever else it needs to go. So there is a feedback from the flow meter back to the PD pump, and the PD pump is run by a variable frequency drive. So the raw material is dosed into the primary flow at a target flow rate, and so we'll be talking through how do we control to the target flow rate. The flow rate that is desired comes from a percentage in a formula or some other process design. So first, it all starts with the control room. So this is where the magic happens. There are a series of HMIs, which are human-machine interfaces that the operator must interact with. And a lot of it happens automatically, but there are times where the operator needs to make a decision. And there is just a massive amount of data that is flowing through these processes. So it's very important to make it very clear what the operator needs to decide and what just needs to happen on its own. So from here, the example that we're talking through is say an operator needs to make some sort of decision that then needs to result in a change out in the field. So this is a close-up of an HMI. This is just a screenshot that I found on the web. And so picture in the upper left-hand corner, it says cold water. It says there's a flow rate and there's a target. So this process is not running, but at some point it will be running, and we want that flow rate to equal the target. And the operator knows what's happening by looking at this HMI, and they're reacting to alarms, and any input that the operator makes through the HMI gets passed through to the PLC, which is where the data then gets manipulated and converted into power that gets sent out to processes out in the field. So from the HMI, the information goes to the PLC. The PLC will be in racks, which are basically big electrical boxes that you'll see out in the field. And PLC stands for Programmable Logic Controller. There's a program that runs on the PLC. So the program is, which is the set of instructions that needs to happen for the process to be controlled correctly. The program defines when each pump, valve, or motor turns off or on, and it turns the operator instructions into actions in the field. So if a operator presses start on a process, and multiple pumps are supposed to start up at the same time, the PLC is what actually starts to send that signal to start off to the VFD. So the variable frequency drive is what converts both the on-off and the speed commands from the PLC into power for the pump's motor. So a pump is driven by a series of sinusoidal waves that the higher the frequency of the wave, the faster the pump is turning. And if there is no power going through, then the pump is not running. So the VFD is sending the power to the motor. The motor is then turning the pump. The pump is what actually pumps the liquid. So you can see that in the picture here that there's an inlet on the pump side. There's looks like a 3-inch triclover fitting. That is where your liquid will either be coming in or out of the pump. So we have liquid coming into the pump and out of the pump And from the pump, we are heading towards our final destination. But before we get there, we are measuring how much of the flow is actually there. And so for that, we use a flow meter. There are different types. A very common type of brand is Micromotion, and it is a Coriolis flow meter, which is just a really cool concept that that people can figure out how to make this. There are two coils. There are two loops. These two flow paths are being forced to oscillate, but exactly how much they oscillate is an indication of how much flow is going through there. So these are very sensitive pieces of equipment that give very accurate indications of the flow rate going through there. So we know what the flow is, and the PLC has to make a decision. If the flow rate is too high, it will tell the VFD to slow down. If the flow rate is too low, then the PLC is going to tell the VFD. PLC is going to tell the VFD to speed up. So this is the feedback loop, not putting all the pieces together. And there are many different parameters that go into defining how this loop is tuned. If it's very far away, we could tell the VFD to react extremely fast. The risk there is that the flow rate will jump to the other side of the set point, and we end up just chasing our tail and end up just swinging back and forth of different sides of the set point. So moving on to another example process that uses all the exact same principles but a slightly different setup. So this was our setup. We had the PD pump that's on a VFD, and it's just the flow meter telling the VFD slash motor slash pump to slow down or speed up. Another system is we are sending a constant pressure, so about in the middle of the screen you see that there's a constant pressure that is then being manipulated by a flow control valve. So the flow control valve is on the inlet side, there's a constant pressure, and then it opens and closes the valve based off of what the flow meter sees as it needing to do. So back near the storage tank, we still have a positive displacement pump. The PD pump is just running at a constant output, and this could be really any kind of pump running on a constant output. And the back pressure regulator on that recirculation line exists to provide a constant pressure. And then from the downstream of the flow control valve, there's just an open-close valve, and then it goes into the main header or storage tank or the next step of the process. So this exact same setup could be accomplished with using a centrifugal pump instead of a PD pump. The centrifugal pump has no problem being deadheaded while it's running. It will just, in general, supply a constant pressure to our flow control valve. So here, instead of having the flow meter telling the PLC, which tells the VFD to control the pump, it is controlling the flow control valve. So basically, if the flow rate is too low, it tells the flow control valve to open up. If the flow is too high, then it tells the flow control valve to close a little bit. And again, we have the same type of loop tuning parameters that we have with the other setup. So in conclusion, we've talked through the example process flow diagram of having a PD pump on a VFD, and there is just, we could be talking about any type of liquid. We could be talking about an ethanol dosed into fuel, or surfactant dosed into a surface cleaner, dye dosed into toothpaste. There's many consumer products will have preservatives that have to be dosed in, the flavoring dosed into beer. This type of setup, and any of the types of setups that we talked about, are in any kind of process you can think of. And the way that this is accomplished is a series of HMIs, PLCs, VFDs, and flow meters all put together, where the flow meter is providing feedback to the PLC, which is telling the VFD or flow control valve how to react. And we talked about similar systems that at first we were looking at the PD pump that has on a VFD, but analogous systems could have the PD pump with the back pressure regulator that goes to the flow control valve. Or we could have the centrifugal pump that is sending a constant pressure to the flow control valve. So if you're still there and you appreciated this video, please comment below on what you're interested in learning more about, and I'd love to create a video about it, or we can try to figure out how to help you in what you're trying to learn. Also, please subscribe. Thanks. Bye-bye.